Let us start the lecture. In this lecture, we are going to discuss about distance of closest approach. Yes, one. Then see, let this is a atom, and this red color circle is a nucleus. As you know, nucleus is a positive charge, and then these white lines are actually the path of projected alpha particles. Then just see the third one, the third path of alpha particle. Here, we can conclude that alpha particle retraces its path. Yes or no? Then just see. As you know, nucleus is positive charge and alpha particle also positive charge. So the electrostatic force of repulsion arises here, and the alpha particle from this point starts retracing its path. And the distance from this point to the center of nucleus is called distance of closest approach. Okay. Then how you can define that? The minimum distance from the nucleus up to which the alpha particle approaches is called the distance of closest approach. Okay. Then let us write the charge of alpha particle is plus 2, and then the charge of nucleus is, we can write, plus Jd. Yes or no? After then, if K alpha is the kinetic energy of projected alpha particles, then at this point kinetic energy of alpha particle completely changes to electrostatic potential energy. So कौन पाइंगे क्या सही पॉइंट रे आसिक अल्फा पार्टिकल किटे किस समय रही जीवो तापर कोन करिवो स्टार्ट करिवो रिट्रेस करिवा रही गला माने कोन पोटेंशियल एनर्जी गला नै कि तो एटा पोटेंशियल एनर्जी आसिला कोन पई ड्यू टू द फोर्स ऑफ रिपल्सन दैट इज द फोर्स इलेक्ट्रोस्टैटिक फोर्स ऑफ रिपल्सन. So here we have to take the electrostatic potential energy, and we know the formula for electrostatic potential energy is 1/4 pi epsilon naught q1 q2 by r. Yes or no? So what you got here? In place of q1 we can write plus 2e. In place of q2 we can write plus jd. Yes or no? And then in place of r we can write r naught, the distance of closest approach. At distance of closest approach, the kinetic energy of alpha particle is converted into electrostatic potential energy. That means here we can write at distance of closest approach k alpha equal to u. Yes or no? K alpha equal to u. Then what you got here? Or you can also write k alpha equal to 1/4 pi epsilon naught 2 pi jd square by r naught. Yes or no? Then to find out r naught, we have to write, we can write r naught equal to 1/4 pi epsilon naught 2 jd square by k alpha. By cross multiplying this we can get. Yes or no? And this is the required expression for the distance of closest approach. Yes or no? R naught is the distance of closest approach. Oh, you know, 1/4 pi epsilon naught is a constant, 9 into 10 to the power 9 Newton meter square, Coulomb power -2. Then 2 is constant, Z the atomic number, then atomic number of the target nucleus is the charge of electron, then K alpha. Now how you can find the K alpha? You can find K alpha in two ways. If mass and velocity of mass and velocity of alpha particle is given, then kinetic energy can be written as half mv square. You know this, yes or no? And then if the charge of alpha particle is given and the potential which is given to this alpha particle is given, then the kinetic energy of alpha particle can be written as q into v. Yes or no? This q is the charge of alpha particle, and then this v is the potential difference, or you can say potential also here. Then we have to write another formula actually here. This are not this distance of closest approach formula is for alpha particle. When alpha particle approaches a target nucleus, then if a question is asked related to proton, that means a proton is approached to the target nucleus, then what is the distance of closest approach? The formula for distance of closest approach, r naught can be written as r naught equal to 1/4 pi epsilon naught jd square by k alpha. Then we don't have to write 2 here, because for alpha particle we just have to write 2e, charge of alpha particle. But for proton we can write charge is e only. Yes or no? Plus e. So here we have to write jd square by k alpha, and this is for proton actually, and this is for alpha particle. This is all about the distance of closest approach. First we have to write the given. Here alpha particle is given, so we can write q1 is our plus 2e. Yes or no? And then energy of 5 MeV. Energy of 5 MeV means kinetic energy is given 5 mega electron volt. We have to convert this into joule, so we can write also 5 into 1.6 into 10 to the power minus 13 joule. Yes or no? The conversion of mega electron volt to joule, 1.6 into 10 minus 13. Then is scattered through 180 degree. Theta is given 180 degree. That is at this angle, alpha particle retraces its path. Then uranium nucleus is given. Uranium nucleus is given means here Z is equal to 92. Z is equal to 92. That means here you can write Q2 is equal to plus ZD. Yes or no? So you can write 92E. Okay. Then what is the formula for distance of closest approach? And here alpha particle is given. So you can write 1 by 4 pi epsilon naught 2Z square by K alpha. Yes or no? Yes, see? Here we just have to put these given values. 2 in place of Z we can write 92. In place of E we can write 1.6 into 10 minus 19 square upon. In place of K alpha we can write 5 into 1.6 into 10 power minus 13. Calculate the speed at which a beam of proton has to fire at a sheet of silver foil if the protons are able to approach to within 2.4 into 10 to the power minus 14 meter of the silver nucleus. Here Z is given 47. Yes or no? Then see, formula for distance of closest approach is, as you know, R naught equal to 1 by 4 pi epsilon naught Z square upon K alpha. Yes or no? And then Z is given 47. Yes or no? A silver foil means Z is 47 is given. Then 2.4 into the minus 14 meters here R naught is given. R naught is given 2.4 into 10 power minus 14 meter. Yes or no? And then we have to calculate the speed. Okay. V is, he asked V. Then see, from this here you can write K alpha can be written as then in place of 1 by 4 by epsilon naught we can write 9 into 10 to the power 9. Then in place of Z we can write 47. In place of A we can write 1.6 into 10 to the power minus 19 square upon R naught we can write 2.4 into 10 power minus 14. Then solving this we can get, you can get 451.2 into 10 to the power minus 15. K alpha means you have to write the unit joule. We got K alpha. So how you can find V? We know the formula for K alpha is half mv square. Yes or no? And from this we can write V square equal to, and this same is your mass of proton. In place of mass of proton we can write 1.672 into 10 to the power minus 27 kg. Yes or no? Just write down here. Then by solving this, what you got here? Here you got V. Here you got V square term. So to find out V, we have to write, and this becomes 23.21 into 10 power 6, and this is meter per second. This is a required answer, a velocity of the proton. Yes or no? This is all about the lecture.